Welcome all of you. We will have a discussion about Beckmann rearrangement in this video. What is Beckmann rearrangement? It is a conversion of ketoxin into amides using H plus acid induced conversion of ketoxin into amides is simply called as a Beckmann rearrangement reaction. And this is our Beckmann. Is Ernest Otto Beckmann is a pharmacist. Is known for two things he has given. One is our Beckmann differential thermometer. Here for the display here, Beckmann differential thermometer. Another one is our Beckmann rearrangement as a ketoxin into amides using H plus ions. So the various definitions are here. Definitions only with different points I'm giving, but all those things are similar points. So in different books, we are finding a different type of our wordings. It is a rearrangement of an oxime functional group into the substituted amides. I'm repeating, rearrangement of an oxime into substituted amide, or otherwise acid-induced rearrangement of oxime to give amides. Acid catalyzed conversion of ketoxin into N-substituted amides. So all those three definitions are similar, and we can have for examination point of view, can have acid catalyzed conversion of ketoxin into N-substituted amides. An example for our nothing but our Beckmann rearrangement. And this Beckmann rearrangement reaction is related to the other rearrangement reactions in that is our Hoffman Smith rearrangement and Curtius rearrangement reactions. In that, electropositive nitrogen is formed that indicates for a migration. Our alkyl migration or any other group, whichever the be the group, it may be migrated towards that one. So that Beckmann rearrangement here, our migration of a group from carbon to electron deficient nitrogen is given here. Now, ketoxin here. What is ketoxin means? So we have given you a two different R and R prime. And previously it is nothing but our carbonyl compound. So carbonyl compound means our aldehydes or ketones. Along with hydroxylamine is involved for the reaction. Removal of water will result into the oxime. And if the starting material is a keto, it is an ketoxin. Starting material is an aldehyde, it is an aldehyde. So now our reaction is very particular about our ketoxin, so that R group are differ and we are getting our starting material is a carbonyl compound, that is a ketone. So ketone to hydroxylamine reaction into get our product as ketoxin here. And we have using our H plus ions, concentrated sulfuric acid and heat the content are getting your rearranged product is our nothing but our amides, which is nothing but our N substituted. And these are the various acidic reagents used as a catalyst which provides the H plus ions. And we have the example here, sulfuric acid and thionyl chloride SO3, P2O5, PCl5, C6H5SO, Cl. All those things is given as an example for our Beckmann rearrangement reaction. And simply migration of groups for during the reaction. Okay, one group is migrating. Most of the reagent reactions are depends on the migrating aptitude. Which one will migrate here? Whether alkyl group migrates or aryl group migrates, or some cases simple proton may migrate or methyl group migrate like that. Any of the things, the fashion, it may be a primary or secondary or tertiary, like various things is given in the migrating aptitude. Provided in the case of Beckmann rearrangement reaction, the migrating group does not depends on the migrating aptitude, provided it depends on the orientation of the group, that is our oxime N. That OH group, whichever is present, the trans to the OH group or anti to the OH group is a group of migrating. So that you find out the OH group presence there. Which one is trans to the OH group? That group will migrate and get your product so that the reaction is highly stereospecific. And the rearrangement reaction has also been successfully performed on haloimines and nitrones, cyclic oximes and haloimines yield yeah, lactam as the. Now this is an mechanism in this slide. Ketoxin here. Already we have mentioned you about that H plus ions catalyze reactions. This so H plus ions come over here. What will happen? It is added to it. It make a H2O plus here. And what will happen in the first stage? H plus ions is added to here to form a H2O and removal of water make them our bond is migrating towards here and R1 migrating to nitrogen. In such a way that we are getting a R2C triple bond N plus R1. I am repeating here removal of our water so that the positive charge is goes to nitrogen. And similarly, this bond migrate to here to form a nitrate C triple bond N. Okay, and once it goes the nitrogen, the R1 is migrated to nitrogen. So our migrating product here R2C bond N plus R1. So this is the resonance. The bond implies that resonance. So what will happen? This bond goes to here so that the positive charge goes to here. Make a carbocation. So our rearranged product here C plus R2 C double bond N and R1. I am repeating C R2 plus carbocation come over here and again water is added to here to make a different product. See that previously N carries the H2O plus. Now we have a addition of this H2O will result into C carries H2O. Okay. Now already we have pointed out that is a H plus ion catalyzed acid induced reaction. Catalyzed means what will happen? Catalyzed must go back after reaction is over. So this goes here in such a way that the H plus ions is cleaved from the reaction to make a OH. For that our product is C R2C OH double bond N and so the rearrangement is done here, conversion of oxime into our N substituted amides. And tautomers, the tautomerism, the rearranged product is goes like here, tautomerism, enol tautomerism, enol keto conversion takes place to get our and as the product. Simply ketoxime H plus ions is added. Second stage removal of water to make a nitrile and migration takes place to make a carbocation. Addition of water to take a CH2O plus and removal of H plus ions result in enol converted to. So this is a Beckmann rearrangement mechanism. And some more examples given here in this slide. Ketoxime to amides. And sometimes in the competitive examinations, they may give starting materials like our ketone. One ketone is given hydroxylamine to make a ketoxin and acid catalyst reaction result into the amides. Our Beckmann rearrangement. Another example here, cyclohexanone is given one keto compound and hydroxylamine is added to make a cyclohexanone oxime is formed here. Now H plus ions is added to here. Here the Beckmann rearrangement is facilitated and what will happen immediately? H plus ions is added to here to form a H2O plus. Now water is removed and positive charge migrate towards the nitrogen. And what will happen? The migration takes place. So this bond migrated towards here to make a lactam. So this is called caprolactam as a final product of our Beckmann rearrangement reaction. And this is one applications of rearrangement Beckmann rearrangement reaction is given. Sometimes in the examination, competitive examination points, they may give you a starting material of our phenol and how the phenol is converted into acetaminophen, which is nothing but a paracetamol. Okay, so OH, the phenolic group here, acetylation will result into the 4-hydroxyacetophenol and hydroxylamine added making to the oxime. So now these stages is different from our Beckmann rearrangement. Once oxime is formed, so this is one R group, this is another R group, so that it is a ketoxime is from over here. So what will happen? So OH group here. So of course our rearrangement reaction is OH group, so that this trans to OH will be migrating. So this will be migrating. So that our trans to the migrating group is very important. Okay, so that in the case of our oxime is come over here, and any type of our acid reagents, trifluoroacetic acid, thionyl chloride, will result into the Beckmann rearrangement reactions to get our acetaminophen or paracetamol as a product. So sometimes this is highly useful for the conversion. The Beckmann rearrangement make use of these things in right way for the competitive examination. Thanks for watching this video. Like it, subscribe it, and share it for more number of videos. Thank you.